Okay, so there are three important laws that Isaac Newton came up with, and these are things that you will come across and again, and they'll be really useful for the next topic that we move on to. So I'm just going to summarize them in this video. So Newton's first law, so there's three laws. Newton's first law is an object will remain at rest or travel at a constant speed unless an unbalanced force acts on it. So, i.e., if something is at rest or if it's traveling at a constant speed, its forces will be balanced. So, if something is at rest, say a car, let's just use cars. There we go, my beautiful drawing of a car there. If it's at rest, then it's not moving forward or backwards, it's stationary, but it still has balanced forces on it because it will have a force down the way, its weight, but it will also have what we call a reaction force from the floor upwards to stop it falling through the floor, and they'll be balanced, so it won't be moving at all. Okay, so something that's at rest will not have unbalanced forces on it. It will have balanced forces, but it will just have the downwards and upwards forces that are balanced. If we've got this car moving at a constant speed, however, so there we go, my beautiful drawing of a car again, you'll still have your balance forces up and down to stop falling through the ground, so your weight downwards and the reaction force from the ground upwards to stop it falling through the ground. But you'll also have balance forces forwards and backwards. So the forwards and backwards force in a car will be the engine force. So if we say this is our forwards force, engine force. And you'll also have the backwards force, which will be your air resistance and your friction. And if it's moving at a constant speed, they will be equal to each other. So at rest, we have what we call the weight and the reaction force, i.e. the force upwards from the ground to stop it falling through the ground, and they're equal to each other. So let's just say R equals W. And again, if constant speed, then F, the frictional force, equals the engine force, and also R equals W again. So that's only if something is at rest or at constant speed. Okay, so that's Newton's first law. If something is at rest or if something is moving at constant speed, there are balanced forces acting upon it. So, for example, a rocket in space, in deep space, there's no air resistance, there's no friction to slow it down. So if a rocket's moving at a constant speed in deep space, it will continue to move at a constant speed in deep space because there's nothing to stop it. So it just continue moving in a straight line at constant speeds. So Newton's second law is related to the first one. If an unbalanced force acts on an object, so if we have that unbalanced force on the object, so one force is bigger than the other, the object will accelerate in the direction of the force, or it might decelerate because if it accelerates in the direction of the backwards force, that's decelerating. The acceleration will depend on the unbalanced force and the mass. So what do we mean by this unbalanced force? So we said that if something's got balanced forces, it's traveling at constant speed. So I'll draw my car again. Okay. Now, in this case, if our engine force is bigger than our frictional force, then the car will accelerate in the direction of the bigger force. So in this case, the unbalanced force. So we've got an acceleration there. And if we wanted to calculate the unbalanced force, we would take the smallest from the biggest. So unbalanced force would be equal to E minus F. So there's an acceleration in the direction of the unbalanced force. And obviously, if you put a bigger engine force, if you push something with a bigger force, it will have a bigger acceleration. So bigger force, bigger unbalanced force will give you a bigger acceleration. Okay, so that's how the acceleration, how the unbalanced force affects the acceleration. In terms of mass, if you've got a little toy car and then you've got a huge, really big, heavy one, like that, if you give them the same push forwards, so if we say they have the same engine force, same size engine force, they've still got the same unbalanced force, but if one is really big, so we'll call that capital M or we'll call that little m, if one's got a really big mass, if you think about it, if you are pushing quite a small stone along the floor, it's relatively easy to push. If you pushed a huge boulder with the same force, it wouldn't really move very far at all, would it? So the bigger the mass, the more difficult it is for it to move. So the bigger the mass, the lower the acceleration, because it wouldn't be as fast as if you pushed it with the same force. So the bigger the mass, smaller acceleration. Okay, so we said the bigger the force, the bigger the acceleration, and we said the bigger the mass, the smaller the acceleration. So that means the force is proportional to the acceleration. As one goes up, the other goes up. So force is proportional, that sign is proportional to acceleration. And all that means is if one goes up, the other goes up. But mass or an acceleration is inversely proportional to mass. So we can write that like this. So that means if acceleration goes up, mass goes down, or if mass goes up, acceleration goes down, or if mass goes down, acceleration goes up. So that's all those symbols mean. So what we've got if we combine those is we've got F is proportional to A, and we've got 1 over M is proportional to A. So if we combine them, F over M is proportional to A. So we can rewrite that as F, if we just rearrange it, you can just rearrange it like there was an equal sign in it. F is proportional to M times A. And we can also rewrite a proportional sign as F equals a constant times mass times acceleration. And in this case, our constant is just 1. So we've got F equals MA. And that's basically the shorthand way of writing Newton's second law, force equals mass times acceleration. So acceleration is inversely proportional to mass. So as acceleration goes up, mass goes down, or if mass goes up, acceleration goes down. And force is proportional to acceleration. So as force goes up, acceleration goes up. And finally, Newton's third law. Every action has an equal and opposite reaction. So, for example, if we have a rocket, okay, and what happens with the rocket is the exhaust fumes are sent out the bottom. So you get like a fire out the bottom. And we have an equal and opposite reaction in the opposite direction. So what happens is those exhaust fumes get pushed down, but that pushes the rocket up in an equal and opposite way. So the bigger the force down, the equal size force up again in the same way. Same kind of thing as if you were on maybe a skateboard. My drawings are excellent today. Okay, if you were on a skateboard and you threw something in that direction, like you threw, I don't know, a tin of beans. I don't know why you'd have a tin of beans on a skateboard, but basketball, something like that. If you threw something in that direction, then your skateboard would move in the opposite direction with the equal force. So every action has an equal and opposite reaction. So if A exerts a force on B, then B exerts an equal and opposite force on A. Another example is if you blow up a balloon. This is my diagram of a balloon. Don't tie it, so you blow it up and then you let go of it. The air rushes out in that direction, but the balloon moves in that direction because the air is rushing out in one direction, but there's an equal and opposite force on the balloon in the other direction, which makes the balloon whiz in the other direction. And there you have Newton's 3 laws of motion.